Hello, hi. Check one, check one, check one, check one. This is Skinny James, aka Zero Stars, aka The Beast. Welcome, welcome, welcome. I'm here to talk about a project I've been working on called Hokusai. Um, Today, I want to talk about just layouting and how um, the layouting in Hokusai is a little bit different than something like HTML. And for those who are just joining, Hokusai is just a backend Ruby framework for writing GUI applications. Um, it works by generating a list of render commands that are agnostic, and then backends are written around that to pass them to a graphics library. So let's just get started. I'm going to start a new project with a gem file. We want to source Ruby gems, of course, and then we want to pull on this gem. It's called Hokusai Zero. The name of the gem is called Hokusai Zero. And it's yeah, it'll pull on the library for us. So let's install it. The actual install might take a little longer on your machine because it has to build a lot of native libraries, and including tree sitter um, and the AST part, the AST stuff for Hokusai. So I'm gonna make a new folder called demo, and we're gonna make a new app, demo rex rectangles .rb, and this is going to be our working space. I need to pull in a couple requirements, dependencies, including Hokusai, and then we also pull in a backend for Hokusai. So the backends sort of work like right now Hokusai ships with Raylib and SDL2, um, but you can write any number of backends. I'm currently working on a native backend. So the way it works, before I get into it, is we're going to make Hokusai, everything's a block, which means that everything's a class that inherits from Hokusai block. So when we pass that class to a backend, it'll render it kind of like ind independently of like a context. So um, the layouting in particular works like, um, I'll show you. Well, let's just kind of do, let me see here, Hokusai block. So we inherit from Hokusai block. Any block really just needs to declare a template, and the templates are written with a custom grammar called HML. So we'll say template, this is the directive, and then we can pass it something called virtual, which is a keyword in the HML to let us know that we won't be using this template, we'll be using a render command. Um, so we can define, if we override a render method, it takes a canvas, and then we can draw with it pretty easily, and we can make commands. So like one of the commands is rect, one of the commands is circle, one of the commands is, let's see, shader begin, text, stuff like that. So right now we just are concerned with drawing a rect from scratch. So we take the canvas, will tell us where in the layout we should draw. As the apps become more complicated, the canvas becomes more helpful, and I'll show you that in a second. So right now, like, it's just going to pass the screen dimensions. So canvas.x, canvas.y, canvas.width, and canvas.height, and that passes a command parameter to the block. And then we can also add additional features like color. Um, and I want to make this color dynamic. So one of the cool parts about blocks here are that we can define computed properties, such as color, and give it a default. Actually, I'm just going to give it this. We can pass an array. Let's see here. Let's make it, I don't know, red. Oh, ooh, ooh, ooh. And then we can pass it away to convert the block. I can speak more about conversions later, but Hokusai color is what we're aiming to convert this array into. And so we can just pass it the color now. That method's available to us, and we can pass it down. So we have a rectangle class, which is really nice. It'll work just fine, and then we can just use the app, which can inherit also from Hokusai block. And now we're going to actually use this component in our template. And the way we do that is by declaring the template directive again, and then we can kind of just pull this rect in. So we can give it properties. We can define its properties as you would in like Vue or React. But we want to change the color or color. There's different ways to define properties. I'm going to go through all of them, but first we're just going to do a static property. So the color could be, we're going to make this color. Actually, we're not even going to define a color on it. We're going to let you use the default. So let's do that first, and then we can try to show, I can demo the other properties. So we want to do this macro called uses, a class method, and we want to define the keyword of the template name right here, rect, and then we want to pass the class, the Hokusai block class that it belongs, that generates that component. And so that's about it. Let's see here. We should have, so right now we should be rendering a red rectangle. So if we do Hokusai backends, raylib backend, run app, and we can configure this backend with different properties. Right now I'm just going to give it a title, so rectangle example, and we want to give it a width and a height. 500, no, let's do 600, and config height equals 500. Alright, so we have this like whole app here, and it's pretty simple, but it's just here to demo kind of like how the layouting works. So in order to run this, I have to run raylib path, and that defines where the raylib path comes from. We also do a bundle exec Ruby. I can use the just-in-time compiler, and we can do demo rectangles.rb. So let's go ahead and run that. So yeah, we get this red rectangle, which is what we expected, but this is where things get kind of interesting. Since Hokusai, like the way Hokusai templating works is that a parent node, which is rect right here, will know all of its children by default. So it knows all the widths and heights and divvies up the space, the available space between its children, much like Flexbox. So if I say, I'm going to pull on another component here, and it's called vBlock, and the whole purpose of vBlock, Hokusai, is just to render things vertically or horizontally, and that's its kind of purpose. So there's a property on Canvas that says like canvas vertical equals, true or false, and that will render its children, and I'll get to children in a minute because we're not even yielding this canvas right now, but yeah, we should yield the canvas after every render. That way the children can then render as well. In this case, we want to define this vBlock, and that renders children vertically, but the default node, default parent node is already a vBlock, so we can just do the rect again. We'll pull in vBlock in a second, but I want to show you how this works. Rect, and we'll make this color. We use a static property, which is just the key equals the color, and then we'll do green rectangle. Alright, let's try that again. So notice that the rectangles are vertically aligned, and also the available space is evened out between the two. So if I make this bigger, if I make this smaller, the available space will always be divvied out correctly, or to this purpose. So if we want to make this rectangle like a height of, let's say, like 50, then what's going to happen is this rectangle is going to be 50, and this rectangle is going to take up the remainder of the space. So that's kind of nice. It's a feature of Hokusai, I think, that makes it a lot easier to reason about what's happening with the layout instead of infinite scrolling. I'm going to leave that alone for now, and we're going to try using vBlock and hblock. So hblock, Hokusai blocks, hblock will render its children horizontally. And so if we do this, if I put this under an hblock, and these are the children of hblock, then what will happen is you'll see something a little bit different than what we saw before, which is now that these are horizontal. And like I said, the space is divvied out evenly, and let's say we want to um, give this a height again, 50. Then we'll see the same kind of pattern happen. Um, oh, this is a height. Sorry, I meant to give it a width. With H block, you need like we're trying to say it's wide, like 50 wide. So then, yeah, we'll see the same kind of thing except horizontally instead of vertically. And then this can get a little bit more complicated. Notice that these canvas properties are changing depending on the rectangle component that's being used. And so that's something that you can also play with. They don't have to, they're just suggestions. They don't have to be the X and Y. You can kind of maneuver around them relative to the space one is supposed to be drawing in. But for now, let's just kind of go with that. So we have this H block. We can do another H block. So consider this is a vertical block. The default node is a vertical block, and now we can add two H blocks, and we can say another rect. Let's make this color blue, and I'm going to show you a new or a different way of specifying the color. We're not changing the color at all, so we can use these static styles, much like CSS, but a little bit different. So we have the style directive, and then we can say like blue rectangle, blue style, something like that. And we can define props. So these props can be anything. They're kind of arbitrary, but like, or they're specific to the the block being used. So this block has a property called color, and we can specify color to that. It's not always going to be color, right? It could be background, it could be something else. But the properties that you can specify on the styles are specific to the component being used. In this case, there's also some functions that we can call. RGB is one of them. So for RGB, we're going to say 0, 0, 255, and I have a little plugin of VS Code that allows me to see the color picker, which is kind of nice, and I can just merge that in to this rectangle with 3 dots, and then voila, we get this style, which is nice too. I like using styles because it's more performant than converting the values each time. So we can see now that we have this this vertical block with this top layout right here, and this bottom layout, and the top is made up of those 2 rectangles, and the bottom is made up of the blue rectangle, and we can see that it stays in proportion to itself the whole time, depending on no matter like what this thing does. This is a really easy way to understand layouting. It does have complications when we get to things like panels or scrolling or things that exceed the viewport, and that's something we'll speak to in a bit. But right now, I just want to give you a sense of the kind of the Hokusai basic layout, and also some of the cool things, the render API right here, and the template API right here. So yeah, that's all for now. Thanks.